to run boot from SAN. So first of all, remember, UCS is designed to be stateless. So stateless means I do not want to run any kind of setting, hardware-based setting, or any kind of installed operating system on my blade. So stateless meaning no settings, or at least not any setting that I cannot program. So no settings, even MAC addresses, UUIDs, everything can be configured, and we do not want to have any local disks. Because if I have disks and I need to RMA the blade, I need to reinstall the operating system. If I would have local disks in the server. If I do not have local disks in the server, or I do not use them, or at least if I take out the blade, I would need to re-plug in the same disks and stuff. And we get new rate controllers and things that kind of can mismatch, causing me data loss. So because we usually will run something like ESXi, which is not very disk based, so we run ESXi runs in the RAM memory, but it does need an installed footprint to, of course, have some files installed on its disk, and those files will be used during the booting of the system and to write logging information and stuff. So because we run ESXi, there's just this small footprint of disk storage that we need, that it can easily be done with either something like an SD card in the server, which is what you most commonly see used, or we use some remote booting, where boot from SAN is the most used version, and it was also the first supported version thing of booting from a remote storage. So we want to boot from a remote storage and not use our local disks. So how to boot from SAN? So we want to boot our server, so our server boots up. This is our server blade. Our server blade wants to boot from some storage that is in the fiber channel network. We're talking about fiber boot from across the fiber channel protocol. So fiber channel boot, I have a fiber channel disk somewhere in my network. So that's connected to an MDS switch, for example. So we have a link to that. It has a floggy, everything is good. The disk is there. The operating system is installed here. So in this disk, or LUN, or anything that your storage array can publish, that I can use in my server. So the OS is installed here. So first thing that I do when I do a boot from SAN is install the operating system, just like I would if I had local disks. Because the system sees these fiber channel disks as local disks. So the OS is installed on this actual disk. We want to have a method by saying, I have my server needs to boot. So how does a server boot? Well, a server boots if it has some disk in it, if it has a disk to boot from. So as soon as it has a disk, I can install my operating system. So where is this disk located? Well, this is either located in the SCSI bus or in the SATA bus. So we either have a disk that we can approach via SATA or via SCSI. So we need to find a way to inject a disk that we do not run in our local system, that there's no physical cable in our system to. We want to have a way to publish a disk, let's say, in the SCSI bus of the system. So the system has some driver, some fiber channel driver, that it can encapsulate those commands, those SCSI commands pointed to, for the server it's a local disk, but the system knows that it is a remote disk. So the system knows what to do with it. And of course we need to tell the server what to do with it. But seen from the operating system, I'm just contacting a SCSI disk inside my server. So when I do boot from SAN, the disk just shows up like a SCSI disk that I plug into the server. Nothing else. And behind the doors, so behind the curtains, we do some magic on the network to make sure that that is published like that. So that's the first thing. So how do we make sure that we inject something on the SCSI bus? Well, we need a driver for that, and that driver needs to be initiated during boot up. So we have a fiber channel boot driver. Now this is a different driver per HBA that we have installed. But extensively last week we have our Menlo and Palo cards. So if I'm running a Menlo card and I have a QLogic module or an Emulex module in my server, when the system boots up, I will see a fiber channel boot driver based on QLogic software or based on Emulex software. If I run the Palo card, if I run my Cisco card, I will also see a Cisco fiber channel boot driver. This fiber channel boot driver is just a driver to contact our HBA. So this fiber channel boot driver has very early access to the HBA of the system. So first, usually the OS boots up, the HBAs get recognized, drivers are installed, and then we can start talking to the fiber channel network. But now this fiber channel boot driver already has access to the HBA in the system. Could be a virtual HBA, of course, when we're running a Palo card. A fiber channel boot driver is being run for every different HBA that we have in our system. So we run this per HBA, this boot process, and every time that this fiber channel boot process is run, the HBA is contacted and a login is performed on the network. So this HBA will do a floggy, just like it would if the OS is already running. So we just do a floggy from the HBA. So that's our first step. So we assume that we have a disk connected to the network that has performed floggy and is available. So now we have a server, and in that server we have an HBA, and that HBA will also do a floggy to our MDS environment. And of course we have a fabric interconnect in between. And remember, my fabric interconnect is an NPV switch, so the NPV switch will only pin the traffic to an uplink and send it out again. So we just go across the fabric interconnect, and here my floggy is performed and the HBA is logged into the network. Then the HBA will start querying the network for available storage. Actually, that's not even the case. What I will do is one of my settings, like I'm configuring the HBA, I'm doing that from a service profile, remember? So one of the things that I specify is the exact worldwide port name of this disk down here. The exact worldwide port name is something that I can know. I need to ask my storage engineers, of course, before that value, but I know exactly which WWPN I need to use and which LUN ID I need to use. So a LUN ID is just a volume identifier on any given disk. So I will touch it briefly now. So assume that the HBA, so the fiber channel boot driver, is aware of the WWPN and the LUN ID of the disk that it wants to access. So I need to tell the server which disk, specific disk, it needs to use. So the system assumes it has connectivity to that disk. So what it will do, going back to my network, I do a floggy. After that, the HBA will do a query. Does it have access to this specific WWPN? So I query the fiber channel network. Can you give me access to this specific WWPN? If the network responds, okay, you have access to that, what does that mean? So the floggy is done. We all saw the floggy happening last time when our HBAs are coming online. We see the floggy coming from the fabric interconnect, going all the way up to our MDS switch, being processed there, and then I have access to my fiber channel network. Once that querying is successful, so what does it take to have the querying done successfully? If I have access, so if my floggy works successfully and I can access the worldwide port name successfully, it means that my zoning is correctly configured. So I need to make sure that the worldwide port name of this specific HBA and the worldwide port name of the disk, that specific worldwide port name, is being zoned together, so they have access to it. So that is a very important step in the process that some people tend to forget. So my floggy is done, I see the disk in my network, but I of course still need to allow traffic being passed between those two hosts in my network. So therefore I need to configure zoning between the HBA and between the disk. So target initiator needs to map. So this means that every disk, that most times, depending on the storage array, I will contact the same worldwide port name and the same LUN ID. towards the same storage array. So that's some magic that the storage array will do. So if I go back to basic fiber channel terminology or basic fiber channel knowledge, I would use a different disk for every server. I need to have a separate volume or a separate disk for each server to boot from. But the storage arrays can virtualize that. So they can present a different disk on the same worldwide port name depending on who logs into it, so who tries to access it. But that's some magic that the EMCs and the NetApps can do. So I will not go into detail about how that works, just assume that it will work. So assume that I need a different volume or a different disk where I can store files, where I can write a master boot record, for example. I need to write boot records. So assume that that exists, and I have a separate disk for each of the servers. But in the real world, I would only have one worldwide port name and one LAN ID to access my boot volume. And then the storage array will figure out which real storage it needs to serve to that specific HBA. So very cool stuff. So those are my 3 steps. I need to enable the fiber channel boot driver. How do I do that? Well, that's of course done in a boot policy. I need to have a disk available, and I need to have my zoning to be in place. So all kinds of specific steps that I need to make sure that I do. So I configure an HBA on the system, I place it in the right vSAN, I make sure the flagging can happen. I configure a boot policy where I specify a special worldwide port name, a dedicated worldwide port name, plus the LAN number. I combine those 2 facts in the boot policy, and I apply that to the server or to the server's profile. Then as soon as the server boots up, after all the GNU OS stuff, everything is configured and the server starts booting, then my boot policy comes into play and says, hey, right, you need to boot from fiber channel. Then the fiber channel boot driver is initiated, then the flagging is done, and then the HBA tries to access the disk. When it can access the disk, that fiber channel boot driver will make sure that the disk is now being presented as being a local SCSI disk. So it's to the system, it's not a fiber channel disk. To the system, it's just a SCSI disk. So first, why do the VHBA names need to match? Well, that depends on where I configure the boot policy. If I configure a separate boot policy, so let's say I go into my UCS manager. Now let me make that a little bit bigger. So when I step into my UCS manager and I configure a boot policy right here, I say plus, then what I need to do is as I test boot, what I do is I need to specify here a VHBA. If I say add this VHBA, it will ask me what is the name of the VHBA that you're going to use. Because this is not related to a service profile configuration yet, it is just a VHBA or just a separate boot policy, then you see that I need to specify that name manually. So that's very important. A very important difference in then if I configure this during a service profile template configuration. Because, so here you see that this VHBA name is a clear text field and I really need to type that manually in there. It cannot check anything because this is just a separate boot policy that I'm creating outside of any other template configuration. So besides running this, I have another place where I can configure boot policies, and that is directly into the service profile template. So if I would configure a service profile template, let me get out of the way here. I go to storage and I assign, let's say, rig FC0 and rig FC1. I go next. Then as soon as I come to my boot policy here, I say, all right, create a specific boot policy, and now I can just select VHBAs. So where do I need to configure them, and where do I need to make sure that even the case sensitivity is correctly matching? That is on this place. So this here I configure my VHBAs. I can just drag and drop them in there, and it will automatically type in the name, which is not a clear text field anymore, it's locked. And now I can drag and drop them, versus that I just need to type the names. So that is the first place where I configure those two, where they need to be consistent. So it depends if you configure that boot policy. I would specify the boot policy here. I would just select one, and that will assume that in my storage configuration, I used the exact proper names for the VHBAs. So the VHBA templates are okay because I can just configure them here, right? So I say, all right, base this on a VHBA template, and then give it a certain name. And this name needs to match in the boot policy that I'm going to select later. Or I'm going to create a separate boot policy, and then I can just drag and drop them. So this is where that matching happens. Then the second question is, how do I configure the UCS to get the zoning from the MDS? Well, that is a different approach. So we talked about last time that we run NPV mode and we run switch mode, right? And NPV mode is just a proxy server. So it just forwards packets coming from a client to the network. The flag is coming from the client. We process them in the network. So that's where I do not need to learn about zones, right? Because I don't care. I don't care on the NPV switch what happens. I just forward packets to an uplink and the network will figure it out. And in the network, my zoning is configured. When do I need to learn zoning from the network? That is when I run fiber channel switch mode. Because in a fiber channel switch mode, I will have a domain ID and I need to make local decisions. And I can only make decisions on traffic forwarding if I have my zoning database. So the Fabric Interconnect will start learning zones, the zoning database, it will start learning that from my fiber channel network. And that is just a given fact in the fiber channel network. The fiber channel protocol supports the distribution of the zoning database to different switches. So therefore the Fabric Interconnect will learn about the zoning database if its uplink is correctly configured, of course, and it's running in switch mode. So only in switch mode I learn about zoning. And then I have some special limitations on how much zones that I can learn, but those are pretty high numbers. So it's just that not a very large topology of zoning cannot be learned in the Fabric Interconnect, but a smaller topology can. And the second reason why I would have zoning in my Fabric Interconnect is if I connect fiber channel appliances. So remember from last time, click cancel here. The other place where I need zoning is if I configure, so here I have some fiber channel ports, uplink fiber channel ports. I can reconfigure these ports for being storage ports. So all the way down here, let me drag it up a little bit. So I can configure this port for being a storage port, meaning I connect an appliance directly to the Fabric Interconnect. I connect a disk array or a storage array directly to the Fabric Interconnect on fiber channel. And then of course, based on normal fiber channel modes, I would need to have zoning in place. If I run UCS 2.0 and I run fiber channel storage ports, then in end host mode, everything is just allowed. That's what's called default zoning. So default zoning is set to permit, and therefore all the clients can talk to the connected appliances. No zoning in place. If I run switch mode and I have appliances connected, I still need a zoning database. So I cannot run appliances. I can run appliances while I'm running in switch mode because then I will use default zoning. But if I'm running an appliance and I have a connection to the network and I'm running in switch mode, then I need to configure the zoning based on the uplink switch. So the uplink switch, I need to configure the zoning between server and appliance. So even though the hosts are not connected, the zoning for that, I need to do that in the network because I cannot do that on the Fabric Interconnect. And usually default zoning is disabled when I connect my Fabric Interconnect to a fiber channel network, an existing fiber channel fabric. So those are two situations where I would learn zoning from the network. So first of all, running in switch mode, and second, if I have an appliance and I have an uplink to the network, then I would start learning zoning. Otherwise, I will use default zoning, running in switch mode or running in end host mode and running only appliances. and that changes in UCS to the 1.